Hello, everyone. It will be kind of an impromptu speech because it was not planned. And the idea is to take you all down this idea, the first step when you start out developing exploits. Have you ever developed exploits? Raise your hands. So 2 people. If you've done it, you cannot participate. So if I ask a question, you cannot reply. The idea is not to spoil my surprise. And if no one is ready to reply, you can help out. But initially we said that this is for people who are learning now, right? It's for you to try and practice. Have you ever heard about Stack Overflow or Stack Play? Many, right, good. Some others not. Basically, a Stack Overflow or this stack getting overflown means that part of the memory that it's hosted on a program to store information, well, there are several functions. So the information surpasses that chunk of memory that it was devoted to it and overrides beyond that spot where it was supposed to end. For a practical demo, for those who have no experience, I brought a beer and a glass. This would be how a program works. It's quite an analogy, right? If a presentation starts with a beer, it is said that it cannot go wrong, so good indication. This would be the bit of memory, the chunk of memory to store information, and I get someone coming to me maliciously, or maybe as a self-protection measure, and on paper, theoretically, this glass would keep, I don't know, 200 ml of water, and beer here is 330 probably. So someone comes maliciously and says, let's see what happens when we add a bit too much. I'll try not to spoil too much. So, overflows. That would be a Stack Overflow. It might seem very simple, and we'll try to simplify it even more. Basically, the idea would be that throughout the presentation, we will try to start from the beginning. If I manage to close out Paint. So, beginning to end with exploit. So, all the way through. This is a demo. This is exploit I wrote some 6 years ago or so. And I've never done it after that. Never run it. So this is for printers. It listens in at a board. But it sends some more information than it's supposed to get, and it overflows. And that was the chunk of memory that was supposed to store it. This is a tool we tend to use at the company I work at. We use Visual Exploit. And what I can do is develop exploits visually. It's so straightforward. So, anyone volunteering? Who's willing to take part here, to come up here? If no hands go up, I'll choose. You can refuse, of course. But please, someone who's never developed exploit, who's willing? Then we will find someone who's got a bit of experience, but who's willing. Okay, come up with me. So first thing we need to do when we are developing an exploit would be we need to handle it. All the way down to the bone. That means send the information so that the buffer is overused, overflown. But we have this print server open. It's a time now for a debugger. Do you know what a debugger is? Good. No need to explain it then. But basically, the debugger will help us analyze a process running in memory. So we go to File, Attach, and we attach it. We look for neprint. And that's where we are. Can you read it from back there, more or less? When we need to read it, I will pan it out, right? Now, push play. We attach it, play, and now it's running. Back to Visual Exploit. This we need to do constantly, because something that goes into cache, we need to restart and attach. This is what we will be doing for 50 minutes or so. I will not leave this room until it works. You can leave as you want. Probably the technicians will kill me, but I'll stay here as long as I want. So, here. Good. What's the question? Neprint. That's the name. That's the exploit's name. Perfect. So, the callback is the IP, where once the exploit is developed, it will be connected to, and it's local host, because we are working on the same Windows we are exploiting. It is remote. Okay. Perfect. So what you see there is two panels, two dashboards. On the left side, oh, great, with your mouse. So that's the protocol, that's the left side. That's where I will produce anything having to do with protocol. Then the right side one is the one that helps me. Sorry, when I say protocol, I mean TCP protocol, login and sending. On the right side, we see all information buffers that I'll be sending. So the classical way to test something, to try something, is send in lots of A's and B's and see what happens. So first of all, drag and drop for everything, right? You drag it to program flow. The other side, right? So perfect. There. Host level toggle. So you write it. And port is 515. We knew this. This is with TCP view and others. And let's see what process each port, open port, belongs to. I could stop there, but say TCP for both, right? Again, I did this 5 years ago, so let's hope it works. Great. So let's start building the buffer. And as I said before, to see if it exploits, let's send a letter, the same letter over and over again, several times, many times, because it's waiting for me to send, I don't know, 200 characters, and I only send 1,000, or who knows, 900. So string. A character string. So A, small a, no, capital A rather. I like it better. And repeat it 1,000 times. Great. So now we can get connected. So we are on. We've got a buffer. And so send it, the one that has so many A letters. So left side, send, drag and drop send, please. And then choose number 1. That's what we have there. Great. So on paper, this is first half and it's ready. Run and see what happens. As you see, so this is the port we change and it's okay. So this is a crash. When you do it, well, people get very happy, so I would applaud now. It's time for an applause. First step. You can get downstairs. I will call someone else later. What happened here? So what happened was I had a memory buffer. What you see here? What you see here is the stack. A stack. Do you know what it is? So you've all studied engineering, right? So basically, this is where you store temporary information. Said information goes up and down all the time. So what happened is, this tiny program stored it into the stack. I overwrote the stack, and as I did so, I changed something, and so my execution, or rather, my execution record, that is the IP record. If you studied first grade engineering, you probably remember, say, CPU, and the IP record where it says what I'm running right now. And that's 414141. Can you tell me what 418 means in ASCII? Capital A. So basically what happened is somehow we overwrote the memory, we went too far, and at a given point we reached a pointer. We wrote a pointer that allowed the execution control to move to 414141. So that's the first step, and it's ready now. Next step. Any ideas? No one. Put the code we want to run there? Well, yeah, but before anything else, is there any other suggestions? This would be the final goal, but we're missing 2 steps in between. Oh, he knows what he's talking about. Yes, that's what he said. We need to add variable characters to know what part of the memory I'm overwriting is where the pointer is located. Pointer that will allow me to handle 414141 and know where I'm headed to. So, someone else, please? Hands up, please. You? So, unfortunately, this is a bit cumbersome because we need to run the debugger again, so you need to attach it. So, go to the debugger. So this can be left open. So bring it online, the printer server. Leave it as it is. Here. That's the printer down there. Great. So run it again. Send the debugger. That is closed. This is the bottom one here. That one. File attached to the process. That's the binware, not the other one. Look for ni print. Attach it. Push play. No, the other one. I'm back to Visual Exploit.
Entonces, lo que nos conviene hacer ahora es, sabemos que tenemos que mandar por lo menos 1000.
So we know that we need at least to send 1,000 so that it crashes, so that we get control of the IP. So therefore, we are going to take out those thousands and we are going to build different memory fragments to create the characters so that we know the IP that we want to replace, because 414141 does not run anything, and actually it is running in the memory that does not exist. So in that memory space there is nothing. So therefore we are going to delete that. Okay, we delete it. We delete that buffer. Great. So we start with this simple string. For instance, 0x10. So capital A, only capital A, please. And now repeat string, check that. And please type in 16. Memory is always aligned in 4. And now, second one, second string, this time with capital B letter. So we repeat that 4 times. Well, 1,000 times now. You were expecting 1,000 times. ABC. And now we are going to send out a big one. So we tried that. It may be good or may be bad. I remember that it was close to the one that I sent. So because we are not going to be here till tomorrow, we do string. We include lots of characters. One more, and this time you type in 900. Then you click on run. You run it. Okay. Debugger. And now notice that IP 444. What character is 444? That's D. Perfect. 42. We know that it should be included in those 16 bytes that we are sending. The memory is aligned in 4 bytes, so 32 bytes. Memory that you see there, the addresses that you see there, are all aligned in 4 bytes, and the 44 ones are misaligned. Now we will repeat everything that we did, but this time we want to pay greater attention to D. So go back to where we were, please close that. Did you do a debug before? No, it is the first time that I'm doing it. Good. Remember that we are sending out 16 Ds. We are going to separate that in 4 different characters. Therefore, we delete D, and then we do 4 Bs, 4 Ds, 4 Fs. So it seems that, well, our life is very exciting, but not. Sometimes it can get a bit boring, actually. And then we will send out again the big buffer, including with very many things in it. Perfect. And now we see the IP is 45, 44, 44, 44. 45 was E. So 3D and 1E is where our buffer is. We will do the same that we did before, but this time we subtract 3 to D's. I know that it is a bit tiring, but the final result will be very good, I promise. You can drag it. So instead of 4 D's this time, we will be having only one. Just one D. And now instead of E, write down Q or R, 4 characters, different characters, and then click on repeat string. Great. This is well done in theory, therefore the IP should turn to WXJ. Are we right? Okay. Go further up in that memory. WBXJ. Good. So we are ready on step number 2. Okay, half an hour to go. We are very close to getting it. Thank you very much for your help. Thank you. Now we should ask 2 questions. What do we use to modify, to change IPs, and where do you want to point at? You want to change it with something which has been mapped so that we have our shellcode there. What do you think we could do? Well, those of you who didn't explain before, do not spoil the answer. Learning is important. What do you think? What do you think we could point it out? Something that we can control. Who said? What are you saying? No, that is later on. You are 5 steps ahead. Well, the best thing would be to point it at an IP, but we are not running anything. We are just in the code. We are just, if I point at localhost, the IP will replace with the IP that I said. So we are going to introduce our shell code. Our shell code, it is inserting our program within other program. By changing the memory of the alien program, we are changing our memory. So therefore, pointer will tell us what I will be running later on, and we will do that in a piece of memory that I control, in the part of the memory that I control. And what is the memory fragment that I control? Any ideas? Look, when I take a look at this screen, I see here that these memory fragments, I can control it. I control it because I can just make it whatever I want it to be. 41, 42. These are the things that I am sending out. Those A, those B's, those C's. Now they are here. So this that was here before, this is the famous stack, basically. Because when I set something through my exploit, I can control things in that stack. I want to point at the stack. And what will you use to point at the stack? Any idea? What would you do? Well, I know it's 7 o'clock in the evening, probably you are all tired. Position where you have your PC stored +1. It means that you can overwrite as much as you want. So, no, this the address when your pointer is stored, when the return pointer is stored, and from there on, you write on your code. And what would that be? Well, it is stored in the stored location +1. Which one is that? -4? So are you asking me to replace IP with -4? Look, the only thing that I can control here is what I write in these memory fragments on the stack. This is what I can control. I have control over this. This is a stack. At a given point in time, the only thing that I know is that if I write here through my program, with my program, what happens? I override this famous buffer that I mentioned before, and this buffer in this specific position, I overwrite it, and then magically the control of the execution will go to that address. That is to say the WXJ that I sent out through my program. This is happening remotely. I'm doing it locally on Windows so that it looks easier. So I could be at the other ends of the internet without me knowing what is happening in the debugger. I just know that I sent a string, a chain of characters, and the only thing that happens is that when I send this QWXJ, execution control goes there, places itself there. Therefore, we said before that I want to point at something that I can control. And what is it that I can control? The buffer that I wrote on the stack, and this is what it allowed me to overwrite the pointer. These are background techniques, but that pointer is the return address. I modified that return address, and then the program has to return that address and then point at QWXJ. Any ideas? Where should I point it at? Just stack, okay, we said that. Okay, I have to point it out at the stack, that's for sure. We all agree on that, but what address? What address are I tapping? So you said that this is the return pointer, QWXJ, the address highlighted in blue, that is the return pointer. So will it go back to the address that I gave it? Yes, this is what it did for me. It wanted to come back, and instead of finding the original address, I said, is that a pointer or a function? The return function pointer. What does it mean? It means that the pointer is stored at the stack. I overwrite it, and then the program wants to go back to the pointer that was stored in the stack. But when it returns, it doesn't go to the original place, but it goes to the place that I overwrote. And I wrote QWXJ. And here, it will just crack the program and it will not continue. What do I point it to? Well, I can point it to the beginning of the stack. What do you think that is? Apparently it says 0012 F8? F8? No, higher up, right at the top. You said that all that was the stack, isn't it? Okay, there. Okay, I would point it there. Come over here, please. I would not point it just at the start of the stack, but I would just point it at the place where I can really control the memory, Please close the debugger, not the visual expert. No, 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 you don't close that. Oh, we were very close. No, that was not it. Okay, higher up, please. Not that one. What is happening? Not that one. Now you open the debugger and the server. And also open the printer server. You go back to debugger, then file attached, and then you choose print. Double click on it, and now you click play. The only problem that we have here is that we don't have the address. Okay, here we are. So what is the address you want to point at? Okay, that's where we start, 12 FAFC. Okay, file exit, please. Exit, great. So click on play. QWXJ, you want to delete it? Please delete it. It is okay as it was. Just click on left and then click right. You have to do it twice. String, now don't go to string, goes to Intel. Now write down 0x because it is hexadecimal, 12 FA. Who can remember? FC. Who believes it has worked? Who says it doesn't work, it didn't work? Who said that it will not work? So there is a tie. 5 of you says it will work, others says it will not work. Good participation here. What happened? Something was wrong? Those who knew that it will not work, surely they knew something, they had some information. So this is what happened. This that you can see here on this panel is the code that is run. So IP was the execution pointer, is pointing at this address. IP points to FB, this address here. This is telling me we are executing an instruction that we cannot execute. But what happened? Actually, all that was executed. I ran all that. If I go all the way up here, I can see like lots of repetition, strange things. And next to the instruction of those X's, we have the hexadecimal character of the instruction. You may notice that it is 41, 41, 41. Therefore, what we sent out was run. But because we sent A and B, then it executes X increments and all the others, and eventually we run 44. 44 were these. We executed A, B, and C. We executed a string like if it were machine code. If we go to FAFC, FC is what you see here. It executed 43, 44. It executed FAFC, and one of them crashed. What is FAFC? Does it ring a bell to you? Who is familiar with it? Only me? Or someone over there? One two zero zero FAFD. Sound familiar to you? No? Return address that we used. One two FAFC. We executed codes our A's and B's and D's, and we also execute the instruction for the return instruction. Now we are ready to run our code. However, it starts running from A, from B, from C, ends up executing our return value. And now let us make a change. Okay, please change string A, and now write down type in this one here, XCC. I will replace A with CC. CC is an instruction that is used to stop debugger execution. So if it is being executed with CC instruction, execution will stop. Did it change or not? Yes, it changed. "11 minutes to go." I have the feeling that 64 has changed. Yes, 64. In the beginning it was 16. I am pretty sure that 64 has changed. Why did it change? Oh yes, I know what happened. It is repeating all the characters, not only one. Okay, let me do it. What happened is that it's taking each of these characters. It understood that instead of being one only character, it understood it as 4 characters. Therefore, because it repeated it 16 times, therefore 64. Please, I don't deserve the applause. I'm going to do it very quickly. Fortunately, I remember some of the values. Okay, we are short of time. So very quickly. So 49 characters up until we get to the return address. I know there are 49, and instead of typing in 49, I will type in 48. 48 times, perfect. And here I'm going to introduce a fragment of assembly code. Okay, see what happens. Integer 0102 FAFC and then 48. So 48 characters before we get to our address. 800 here. Are we attached or not? Now I will run in 3 and then you can take a seat. Okay, so port 1515 again. Yes, it looks like fun, but it is a bit tedious. Why did that happen? Do you know what happened? It did not include the CC that I wanted it to include. Instead of doing that, I'm going to do this. 1, 2, 3, 4, 8 Cs. Then I delete this one. Oh, what can we do? Well, when your presentation is about a demo, these kind of things happen. Okay, I do it. Thank you very much. Okay, here we go again. With lots of optimism. One, two, three, four, five, 8 plus C. I add a string A. I want it to be repeated. 49 minus 4, 45. And now my integer, because 0x12 FAFC. If you were following me, I'm sure that you are completely lost now, but let us go for it. 700. We connect. We said that the port was 115. No, sorry, 515. I have deleted or removed or disabled all the protections. Because operating systems are full of protections, I have disabled those. If everything goes fine, we should be getting. Okay, good. Bravo. What has happened? IP was changed. Now we are seeing the next instruction, not the original one, because IP always shows us the next address, not the original one. However, you may notice that FAFC, it ran int3, and int3 tells the debugger stop. Therefore, we are executing our own code. What I'm going to do now, if, well, Python doesn't crash again, I'm going to introduce my shellcode. What's a shellcode? Windows 32. Shellcode is my own program that has been set up in a specific way, and it will connect to me. It will log on to me. In this case, I have a local connection. But if I were in China, it will log on China, because it does a socket, a connect, and it connects to logs on to the address that I tell it to log on to. But this will not be as easy as that. First of all, we realize that this CCC will not stop the debugger, so we will have to move them out from here. We will have to delete them. When I wrote down 49 A's, the thing is that all those A's were run. It ran all these A's because it believed it were part of my program. But when it executed 12FAFC, that became code, and then the instructions were privileged, could not be run. So therefore, somehow we have to circumvent, we have to skip that 12FAFC. Any ideas to avoid that? To circumvent that? Ideas? Yes, you're right. We wanted to jump over those, to skip those 4 bytes. We are going to run a jump instruction. And you're going to say, you want to jump to my shellcode. This looks like magic. And basically, when this will be run, it will create a jump instruction in assembler, and then it will jump those 4 bytes and it will reach my shellcode in theory. However, the program says that the size of the shellcode is 2 bytes. And for me to reach that address, I needed 49. So 45 plus 2, 47. Then I need to change this 45 to make it 47. Therefore, now I have 49 bytes. And the idea is the following. That address, I will point it at the A's. A's will execute that jump. This will jump 4 bytes and it will execute our shellcode. Now I'll go to debugger. Start again. I'll do the following. We will do what we did before, so that the concept is clear. I will add an integer before everything. And why do I do that? Why do I want the debugger to be stopped and to run my shellcode? So the idea is first that, well, the idea is my C's are executed first, and then through my debugger, I take a look at what's happening and see what happens. We are executing, we are running int3, and now it's 7. This is how these increments are being run. This is this register, the register here is increasing because it says increase register of X. We do that 47 times and jump short. This is the jump. Jump is said, okay, jump 4 bytes. Where will it jump to? It will jump to the start, to the beginning of my shellcode. And therefore, this one, FC, F1, FC, FA, 1210 will be jumped. Who says it will work? Who believes it will work? Okay, higher hope here than before. And who says that it will not work? Okay, no one says that it will not work. Okay, so you have lots of, you trust me a lot. Oh, it didn't work. Why didn't it work? Anyone knows why it didn't work? It is difficult. It's a difficult answer. Those of you who did exploits before, well, now you have a say. You may answer. My shellcode was there, apparently. There was not enough space. That's a possible good answer. Stack has no protection whatsoever. I've removed the protections. Lack of space, that's a possibility, not enough space on the buffer. However, I know that in this case we had enough space in the buffer. Any other possible answer? Well, I know that it is difficult. Yes, it is difficult. 0102 FAFC, that's a good theory. Well, it doesn't jump right away to the stack, but I avoided telling you so or doing that because it was very difficult to explain. And yes, because one was pointing at a stack. Often stack addresses change. Often you use another trick that I'm not going to explain it right now. So it didn't change. Everything was run. Everything was run. The shellcode, everything. I'll tell you what happened. So often when you develop exploit, the following happens. The protocol has some type of parsing. This is similar to HTTP protocols. So what happened was that when it copies the chain of characters, this is done because of the protocol parsing. It is ensuring that there are some characters that are not there. So for instance, 00, what does it mean in hexadecimal? It means end of the chain. I didn't have any 00 in the A or B's, but had I had a 00, it will stop it. It will stop the copying, and only it will cut just a fragment of my shellcode. So somehow I have to create a shellcode with no 00 in it. And other than that, there are other elements included in the protocol, protocol. If I just add 0D, it will not parse it either. It will go and say, oh, that's the end of your string. I will move on to the next one. Therefore, I have to develop a shellcode fulfilling a number of requirements. That is to say, that it filters a list or a number of bad characters. So luckily, Visual Experts allows us to obtain that. Often, how do you do that? In general, instead of sending out the shellcode, I would just send out different characters up until I make it to 255, and then I notice which ones were filtered or when did the chain stop. And then I make a note step by step of all the characters that should not be there. And I brought them all with me because I knew I wouldn't have the time for it. Basically, these characters are these ones. Is 00. Bien. I brought them with me. These are protocol-based characters. All protocols are different. Surely they would all filter different characters. 0x0a, which is basically enter, 0x0d, which is return, ampersand, question mark. Then we also have the space character. Probably it is passing the string whenever it finds a space, then it stops it, and then percentage. Oh, I could die. So today, this is not a good day for demos, or it's not my day for demos. Ampersand, end of question, space, and I will add 0. Okay, we leave it there. These are the characters that it should filter. When it will create a shellcode, we will not use any of those characters. For instance, if in this A I would have a space character or an enter character, I will go and say careful with this when you will run it, because it will stop your string. We start again. Okay, we play it. So now everything should be all right. So shellcode is being run with encoder. Encoder bases itself in my original shellcode. It encodes it in a manner that it does not include any of the characters that I typed in. So please click on run and let's go to debugger. Run it again. Stop. I know what happens. It is taking its time. Why is it taking its time? Because it is encoding. It is looking for the right characters. Once all that is encoded, the shellcode works. Go to that window, that one. Okay, this OS window, this black one, that one. It should be encoding. Well, in theory, it's being encoded. Okay, we open it again and we try it again. So we open debugger, print, we attach, we play. I will be very frustrated if it didn't work. Now MS window, see what it says. Okay. Now it is analyzing. It has just sent it. Debugger didn't notice it. This is a mystery. What happens with debugger is a mystery. Okay. Let me do it. Many things could have gone wrong. Well, those of you who want to leave, you may leave. Okay. This should be working actually. Oh, we just had to wait. It is executing in 3. Notice that we run something, we just had to wait. So function F7. F7. So we are finishing. Jump. One more. Skip, jump. One more. Who says it will work? Who believes it will work? Who believes it won't work? Well, 3 people believe it won't work. Okay, you may leave now. I cannot believe it. it did this to me. I just cannot believe it. Those three were right. I thought it must work. No, I wouldn't leave this place without up until it works. This is very typical of demos. There is a problem with the shell code, clearly. 1200FA. The first characters of the code are not working well. Exit then. Okay, let's do the following. This is a bit of a cheating. This is cheating a bit. I skipped a step. When you develop an exploit, stack is not triggered automatically because the stack changes all the time. In this case, it was fixed, but when you attack other program and another program, that program has stack which is slightly different with slightly different addresses. So what you do is instead of asking it to jump the stack, you said you skip a code fragment that has a jump that is pointing at me. So here there are two things that are pointing at me. One is SC. This is the SC register. This register will always point at something which is mine. That is to say, these CCs. And if I notice SP, it is jumping to 88B. 88B is the beginning of my shellcode. Okay, we try it once more, and if not, we'll do what I said before. It should have worked magically all right. You should all have uploaded, and that should have been it. Well, I will not come back to CyberCamp. Okay, obviously it will take some time because it is shellcode is being encoded, and then it will be sent out. Then I run int3. See what happens. Oh, same thing. Same thing happens. The code is not being properly encoded. -1, that's possible. This is the progress. Notice there are no zeros. Oh yes, there is 100. All right, now no. There's a possible option. One of the possible problems often happens with a stack. Notice that this stack is 0012FB30. I have it now. 0012FB. Well, before it worked because we didn't write anything afterwards, but the 0012 FB, whatever FBFC, that was our return address that we modified. It has a 00 in front, and we said that when it finds a 00, it means it stops the string of characters. Therefore, I would need to find something on my CPU register SCS that it is in a code that allows me to jump that. So we look inside all the modules, in all the libraries in the program. We look something that allows us to make a jump. In this case, as I said before, SP, this continuation here, so let us do it again. I will find an instruction in a module that jumps to SP. I know that my shellcode will start here in SP, right after 0012 FB. I will do it very quickly. I know that you all want to go home now. So search for all commands that say jump SP. Okay, this is a list of all the commands, all the ADLs that have a jump SP somewhere. I'll take this direction and I will put it in my exploit. I will go back to this instruction that has a jump SP. My instruction, instead of going to my buffer, it will go to an ADLL that says jump SP. And then in that jump SP, it will find my memory. So I change this because this in front has this 00, and then I replace it with this address. Okay, we test it, and if we try it, and if it works, I'll tell you later on why it works. Here we go again. Okay, it is encoding now. Well, this time I didn't ask you who believed it would work and who would not believe it worked. I don't have any faith, any hope anymore. It is encoding. It takes some time. Okay, this is the last attempt. Terrible, terrible moments. We go. It ran it. Didn't happen anything. Here we go. Okay, try any command. Okay, I'm not going to do anything. You do it. So you try, dear, who am I? No, down below. And then execute. This has nothing to do with the shellcode, no nothing. This is Python. What happened with the button? A binary code, kind of. So the shellcode works, and now we have problems with the keys. Okay, tap. Well, if you do dir, it executes, it runs dir. Dir. You can send commands and it will run them for you. Yeah, I know that you don't believe me. You don't believe me now. Here we go to File. Here we go. Thank you. Any questions? Any doubts? All possible doubts, I guess. If you have a couple of seconds, I can explain. I can explain jump speed. Do you want me to explain that? Yes, okay. I'm sure that you are enjoying it, he's saying to the graphical reporter. Okay, I explain it to you as long as this mouse works. I will do my best, but this mouse is not good at all. I will run the debugger server. This is like a torture. Okay, to tell you how it works, luckily I remember the line of command. I will take this address, the address that we used in the beginning, 7543 CB 754C8B. I'm sure that in Cyber will not invite me again, or at least next year. So first of all, I will go to that address. So this is the jump SP that we saw before. I will introduce a breakpoint. Remember that our return address, that used to be 0012FAFC, which was the actual stack, I will replace it with jump SP. Jump SP is in any loaded module, in any of the loaded modules. And then from Visual Exploit, I will run this again. If everything works as expected, as it should be, it will stop the execution in jump SP. So when does this auditorium close? All right. So it has run SP again, and this is the very same address. This SP address is 12FB30. which is exactly the same address that we have on stack, 12FB30. Therefore, what I did, if instead of jumping right away to the stack, I jumped to a module that didn't have any 00 in front. Remember that the problem that we had before is that the stack had a 00 character that stopped the string of characters. Therefore, instead of jumping there, I jumped to a module that had a jump SP. The first jump SP was run, and notice what it will be doing. It will jump to SP register, and SP register is pointing exactly at where the shellcode starts, which is F5 whatever. Notice this. The previous address of the shellcode, it is the same address of jump SP. And if I go up, if we compare visual exploit with this, visual exploit, we had 4 C's, CCCC, these ones here, or 3 ones, or 3 C's. Okay, 4 C's, and then it started in 41. So 43 times 41. 41, 43 times. And then we have the jump. And we have this address, 754C8B. Remember that we control everything. We control that fully. When you implement this in a server in a nearby country or not, so in a faraway country, we don't see this. This works kind of, this is automatic. 754C8B. This is the return address. The first thing it does, it runs that address. It takes me to jump SP, and jump SP goes back, returns IP. The IP was taken from the stack, and then it jumps SP, and then it says jumps register SP. Well, there is music here. Surely they will turn down the lights. And that jump SP points right away to the beginning of my shellcode. This doesn't, even if it doesn't look like this is a shellcode. Well, I came all the way from Argentina for this, so I'm not in a rush. So, and if I show you the contents of this SP, this is my shellcode. Now I push F9. So it takes some time. Well, it worked once, it has to work twice. Now jump SP shellcode is running. It goes slowly. I like the music. Oh, it was hidden here. And now I ask, who am I? And then it tells me that I am a student user of this machine. Well, this is all from me. Thank you very much. That's the end of it.